Okay, let me mention a few things about scalars and vectors and get you thinking about vectors in one dimension, which is where we're going to start. So first thing, scalars and vectors. So I can have things like if I have an object, it's going to have some mass, and that mass is just a number, right? So my mass is going to be measured in kilograms in this class, and it only has a number, so it does not have a direction. I can have other things like volume. If I fill up a glass with water, it's going to have some sort of volume. We're going to measure this in liters. And that just has a number. It doesn't have a direction. So we're going to get into most of the things in physics have a direction associated with them. So these are going to be vectors. So these things that have just a number, we'll call this a scalar. Those things that are going to have direction as well. So if I'm going to have a displacement, if I travel from one place to another, I go some distance and then in a particular direction. So there's a combination of both a number and a direction. So in this case, in displacement is going to be measured in meters, and then I'll just say what I'm going to call this to the right. You get to decide your coordinate system, how it's going to work. And we're going to have other things. So velocity is going to be. There's the dog. Velocity is going to be a. It's going to be a long year. Velocity is going to be a vector as well, acceleration and so on. But there are going to be a lot of things as well that aren't obviously vectors. So we get into rotation. Things that are rotating are going to have a direction, which is not necessarily the direction of motion. And we'll get into fields, and fields are going to have directions as well. And we'll get into things like surface areas. And surface areas can also have a vector direction. So it's going to get a little bit trickier. Well, it's going to get a lot trickier as we go along. But right now, we're just going to worry about things that can have a magnitude and a direction. And we're just going to worry about one dimension right now. So anyway, these things are vector quantities. And when I describe these, I need to have a magnitude. There's going to be a unit for the magnitude and then some sort of direction, right? So if we have a surface area of something, we would describe that as meters squared. And if we're treating it as a vector, which we will later in the year, if it's a vector dimension, there's going to have also a direction as well associated with that. Okay, so we're dealing primarily though with things that are in one direction. So the nice thing about vectors is that in physics, at least, you get to change the direction or change the orientation of them, right? So I'm going to have a vector, I can draw it in one line as long as I keep that, the relative angle and magnitude, right? So my magnitude is represented by the length of the arrow, and the direction is designated by the angle of the arrow to my coordinate system here. So as long as I keep that the same, right, I get to move it around as much as I want. So we're going to take a look at this on a simulation. So this is a nice simulation which shows a way of representing vectors. I could put a vector on here. I'll call this A. Right? And this vector has some length, which represents the magnitude, and some direction, which represents the direction of that. So I can change that on this is sort of entertaining. So I could take two vectors. I could take A and B, right? I could have B, point in a completely different direction, different magnitude. And when I combine these together, right, that I can put these end to end. So right now we're only going to be dealing with vectors that are in one dimension, right? So my vector is either going to be going forwards or it's going to be going reverse, right? Those are the only two options, right? And the way I add these together is I'll put them head to tail. So I'm going to take this tail, the head of one, and line it up with the tail of the other. So if I start here, I get grief. If I start here, I'll follow one vector to the end and then the other vector in the opposite direction, and I can find the sum of these, right? So I can find the sum, and this simulation that shows this as this dark blue arrow when I click this box. And so when I add these together, I get this. If I was to subtract these, well, I would take one of these. If I was to subtract B from A, subtracting B would be the same as adding the negative of B. So technically, if I subtracted B from A, I would end up with this. Right? So my original B was something like this. I did subtraction. So we'll worry about adding and subtracting, right? So this is going to be the primary thing that we're going to be doing. We're going to be combining vectors together. And in one dimension is either you're adding or subtracting the entire vector. As we get into two dimensions, it gets a little bit trickier. We'll get into components. So we're going to spend a chunk of time on that. But if I have a two-dimensional vector, so I can represent it as a vector in the x dimension, a vector in the y dimension. And then if I have two that have some awkward thing like that, then when I add these together, I'll be adding together the x and y dimensions, and my sum is going to represent the distance from the start of one to the end of the other. So I can take this dimension, subtract this from it, take this dimension, the y dimension, and add on the second y dimension. So anyway, we're going to come across a lot of vectors. They're going to be in kind of odd places later on, and we're going to have a different way of representing them. But for right now, what I need you to recognize is that a vector quantity is something that's going to have both magnitude and distance, or just magnitude and direction. And for one dimension, we're just either adding or subtracting them. So we're going to get into more complex vectors, and we're going to get to multiplying. Remember dot product and cross product. We're going to get into multiplying vectors a chunk later. But for right now, I need you to recognize them and be able to just add them. Hope that helps. Bye.